So this is another interesting question which asked during the interview at top tech companies. So the question statement is like this. Given two single linked lists, determine if two lists intersect and return intersecting node. So here we need to note that intersection is defined based on reference, not the value. So that is, if the cut node of the first linked list is the exact same node as the jth node of the second linked list, then they are intersecting. So if you look at these examples over here, you can see that these two linked lists over here are intersecting at the node of 7 over here. So first linked list, first node starts from here and it comes until 9, and the second linked list, first node starts from 2 and starts until 6. Then at some point, both these linked lists points to the same node. So at the end, they are pointing to the same tail over here. Now if we have two linked lists like this same two linked lists like this, it means that they are not intersecting. So in this case, they are not intersecting. In this case, they are intersecting. So the question is, how would we detect if these two linked lists intersecting or not? The easy way to identify it to check the last node, because two intersecting lists will always have the same last node. Therefore, we can compare the tail references. But here the problem is we need to return an intersecting node. So how can we find in which node these two linked lists intersecting? So here, if the linked lists were the same length, we could just traverse through them at the same time, and when they collide, this is our intersection. But here again, another question comes to our mind. What if they are not same? So in this case, we just ignore the excess nodes. So how can we do this? So, well, if we know the length of two linked lists, then the difference between these linked lists will give us how many nodes to ignore. So if you look at these two linked lists over here, we can easily see that the size of the length of linked list A is 7 and the length of linked list B is 6. And the difference between them is 1. So this means that we can ignore the first node of the longer linked list from here. And this means that we will ignore the first node, and starting from the second node of the longer list and the first node of the shorter list, we will loop. Then when the loop intersects, we will return the node which is intersecting node. So in our case, if we start to loop from the second node of the longer list, which is list A, and the first node of the shorter list, which is list B, we will continue until we reach the intersecting node. So in this case, we can easily see that the intersecting node is 7. So we are going to return 7 over here. So each time when we are looking through these linked lists over here, we are checking that if these nodes are referencing the same node or not. So if they are referencing same node, this means that this is intersecting nodes. So we can stop over here and return the node in this case. Now here we have identified how can we find out the intersecting nodes in two linked lists. So based on this logic, let's switch to Java and implement our intersection method in practice. Now here, to create our intersection method, we are going to need some helper functions over here. Now the first helper function that we are going to create is to get the cut node. So we are going to use this method inside our intersection method, which will get the cut node from the longest linked list. Because, so as we said before, we have to ignore some nodes from the longer list. So that's why in this case, this method will be helpful for us. Basically, this method returns the cut node from any given linked list in this case. Now the return type of this method will be node type, and the name of method will be get cut node. And as a parameter, it's going to take node, so which will be the head, and integer k, which will be the index of node that we want it to return. So the first thing that I'm going to do, I'm going to create current node over here, which will take the head value, and then we are going to loop through this linked list and find the cut node in this case. So our loop will be like this: while k is greater than 0 and current is not equal to null. In this case, we will continue to the next node. So I will set the current equals to current.next. Then at the end, we are going to return current. So with this, we are returning cut node from the given linked list over here. Then I'm going to start to create our find intersection method. So here I'm going to declare our method like this. So as we said before, our method should return the node in which two linked lists intersect. So that's why the return type will be node. and I'm going to put the name of method find intersection. So this method will take two parameters. The first parameter will be linked list 1. So I'm going to put it like this, linked list 1, and the second parameter will be linked list 2. So then inside this method, the first thing that we are going to do, we are going to check that if the head of any of these linked lists points to null, in this case we are going to return null, because in this case these linked lists are not intersecting. So if list1.head equals null, or list2.head equals null, in this case we are returning null, return null, because they are not intersecting. Then I'm going to continue to write another if condition. So as we mentioned before, the first thing that we are going to do, we are going to check that if the tail of these two linked lists are pointing to the same node. So if their tail is not equal, it means that they are not intersecting, so we will return in this case null also. So I'm going to write it like this: list1, if list1.tail is not equal to list2.tail, then in this case we are going to return null, because in this case also they are not intersecting. Otherwise we are going to continue to our implementation over here. So the first thing that I'm going to do, I'm going to create a node which called shorter, which will be new node in this case. Then I'm going to create another node which will be the longer. Then based on this linked list size, I'm going to identify which one is longer or which one is shorter. So here I'm going to write if condition like this: if list1.size is greater than list2.size, in this case list1 is longer. So in this case I'm going to set longer equals list1.head, and shorter will be list2.head, because in this case list2 is shorter. Otherwise we are going to put reverse. So the longer will be list2, the shorter will be list1. So I'm just going to copy it from here and pass it over here and changing the value. So longer will be list2 and the shorter will be list1. Now after doing so, as we said before, we have to ignore some elements from the longer list. So in this case, as you see over here, we are setting each node over here to the head value. So we are going to start loop through the head of both these linked lists over here. But in this case, we have to ignore some nodes from the longer. So that's why I'm going to set longer to the value that we are getting the get cut node over here. So in this case, longer linked list will not start from the head value for looping. It will ignore excess nodes. So it will start from the node that makes these two linked lists equal. So here I'm going to set longer equals get cut node. So as a head, we are going to set longer. As a cut value, if you find the difference between the size of list1 and list2, then in this case we can find the cut. So I'm going to put it like this: math abs, so list1.size minus list2.size. So I'm putting abs here to convert it to a positive number. Then I'm going to start loop through these linked lists over here. So what I'm going to do, I'm going to write it like this: while shorter is not equal to longer. In this case, for both longer and shorter, we can continue to the next node. So shorter is equal to shorter dot next, and longer will be longer dot next. Now at the end, when our loop finished and when we find that shorter is equal to longer, in this case we can return any of these nodes over here, because in this case they are going to be equals, so we can return any of these. So in this case I'm going to return longer. So with this we have come to the end of this method. So we have implemented our method over here. Basically what we are doing over here is we are just checking that if any head of this linked list points to null, so we are returning null. If the tails are not equal, we are returning null, because in this case they are not intersecting. Otherwise we are finding the first longer list, then we are ignoring the excess nodes from the longer list, and we are continuing to loop through this linked list over here until we find the common node that is referenced by both of these linked lists over here. Now to add same node to the two different linked lists, I'm going to create another method over here which inserts same node to two different linked lists over here. So as you remember, we have created insert node method over here inside this linked list class, but here it's inserting only to these linked lists that we are creating over here. But in this case, I'm going to implement new method which inserts same node to two different linked lists in this case. So in this case, it's not going to return any value. So that's why I'm going to put void. So the name of method will be add same node. So as a parameter, it's going to take two parameters. So the first parameter will be linked list A, and the second parameter will be the type of linked list, which will be linked list B. So each time when we create a node, it's going to add same node at the end of these two linked lists over here. So here we need to put node value also, so it's going to be the type of integer, node value. So the first thing that we are going to do inside this method, we are going to create node, which will be the new node. Then we are going to assign the node value to this new node over here. New node dot value is equal to node value. And then we are going to add this node, new node, at the end of this linked list over here. So to add the node at the end of single linked list, the first thing that we are going to do, we have to point last node's next reference to this node. So I'm going to put it like this, next new node. Then tail has to point to this new node over here. Similarly, same operation will be applicable for linked list B over here. So I'm just going to copy it and change it to linked list B. So with this, we are successfully inserting element to these two linked lists over here. Now let's see how this is working in practice. So as you remember, so in slide we have shown that these two linked lists are intersecting. So I'm going to create same linked list over here and run our method if this is working correct or not. So here we have created a linked list A like this. Then we have inserted these four elements to this linked list over here. Then we have created another linked list over here, and we have inserted these three elements to this linked list over here. So then we are inserting these three elements to both linked lists over here. So this means that our intersecting value is 7. So as is shown in this figure over here. So if we run our method in this case, it should return 7 in this case. If it is returning 7, it means that our linked lists are intersecting and the intersecting node is 7. Now as you can see, after running, the method returns 7. So this means that these two linked lists that we created over here are intersecting at the node of 7. So actually they are intersecting at the node of 7 over here. Now as you can see, we have successfully implemented a method which checks that if these linked lists are intersecting or not. Now let's see what is the time and space complexity for these methods over here. Now the time complexity for this method will be OA plus B, where A is the length of the linked list A and B is the length of the linked list B. Now the space complexity in this case is O1. Now with this question, we have completed this section. So in this section, I have explained the most common questions that are asked in interviews by big companies. So if you understand the logic behind these questions, similar type of questions will be easier to solve. So now here we have come to the end of this section. Now see you in the next section.